So here at the moment, I uploaded the final design of my robot for my arena using Office Lens. I selected this filter as I feel it shows my sketch the way I want it and to describe it. So right here we have the elevation. So the robot is 11.6 centimeters wide and 6.4 cent. No, that's the wheel. 7.2 centimeters in height. I sketch in the wheels, as you can see by just the outline. That's the wheel underneath the actual chassis. I have the ball cast up in front. Also, if you see right here, as I just zoom in, I have very small outline of flooring. As I would say, for my motors and my battery pack up here. Also, with this with this hole right here is where the battery pack's going to be exposed. It'd be more clear as I go through the other views, as this is the elevation. Right here is going to be the actual plate or location the breadboard's going to be placed in. It's 1 centimeter in height and 8.2 centimeters in width. The breadboard be placed in here, but as I go down to the elevation, I mean not elevation, to the plan, it's 12.9 centimeters in length it is, and still about 8.2 in width. So I first go over the front of it. As you can see right here, here's the highlight of the ball caster underneath it. 2 centimeters in diameter, 3 centimeters by 3 centimeters for where it's being placed on. At the ball, it can't be just a ball. The ball for the ball caster has to be placed in a container for it to move freely without falling it off. My mistake, the width of it is 11.6, 8.2 is the front of it. Well, 8.2 by 5.4 is where the breadboard is going to be placed. So the breadboard will fit in there nicely, won't wobble or anything, and that's where the wires will be exposed. So I can change it or upload a new Arduino code without dismantling the chassis as it be exposed. I have I could have made it all squared or cuboid, but I decided to go with this design with a right angle triangle. So even if it does slide, it would just slide against the wall, giving it more rotation if an error occurred with a sensor. This is also where you see the outline of the wheel still, 6.4 still. This right here, the 6.4 by the, if I remember, that's 2 centimeters is the hole where it's going to be exposed. Oh no, sorry, my mistake. 3.4 is where the hole is going to be exposed, so I can put the wires into the breadboard from the motors and the battery pack. And this is the plan for it. Up here is the end view, so this is the side of the chassis. So the ball castle is in place as usual. The wheels are here, 6.4 centimeter is 6.4 centimeters in diameter, 12.9 centimeters in length, and it's 7.2 in height. 5.6 and 1 centimeters for the tray where the breadboard is going to be placed in, as always. As you can see right here, I have a curve going down for the chassis. I didn't want it to make it all square or anything like that, so I find making it a curve even with cardboard it will be more of a refined design. Plus, when I do place the battery pack in here, it be sticking out instead, so the wires can be put in. Now I know it's very hard to see here. Due, this is all one section of the flooring. Right here is where the wires for the motors in here will be exposed to be placed into the breadboard. So the battery pack will be up here separated by different flooring. The reason I want this different separate flooring is I can easily place the battery pack on top of each motors, but the motors are not the same length as the battery pack, so there's going to be a bit of wobbling between each component. With floors separated in them, I can keep the motors in place with in the chassis so they won't wobble around, so they can keep the wheels in straight. And with the weight of the battery pack separated by flooring, the battery pack won't move the motors at all when the robot is operating. As you can see right here, the wheels and the ball capsule have good separation from the ground and the actual chassis. So the chassis for the robot won't be dragging on the ground and move smoothly. And that's the end view for it. So I'll see here from my elevation, my plan and my end view. I find orthographic projection very good to demonstrate it. It's used by architects a lot. So just to go over again quickly, well not quickly, better. This is my elevation. So the front of the robot, if the robot is coming towards you. This is the plan. So when you're looking down on the robot, and this is the end view of the robot, if you were looking at the side of it. Just one more little thing to talk about. This 1.4 by 1 centimeter is a color for a black and white sensor or TCO T5000. It's going to be connected to the breadboard, but the problem is the wires are going to be loose, as I find with previous designs. So a collar will hold the wiring and the sensor in place so it won't wobble at all or shake. And even though, and that's my refined design of my robot, as I just described.